Alright, we have a few more of these types of problems where we're going to continue to use those rules. If I look at this one, I just have that constant out in front, so I'm just going to, or right here, so I'm going to bring it out in front. When I bring that out in front, I can then say it's 3 times whatever this integral is, which happens to be 0, and 3 times 0 is 0. This one right here, it looks like to be the same problem except for it has different bounds, so I'll bring this out front. 3 from 0 to 1 of f of x dx. That really means that I have 3 times this area right here, which happens to be 5. 3 times 5 is 15. My last slide for this section in this day tells me that I have the function that's continuous on the interval from -5 to 5, and we know that from 0 to 5, f of x dx, the area underneath the curve, is 4. So what I'm going to do is, first, I'm going to separate this because I have two functions here. So I'm going to separate this into, from 0 to 5, f of x dx, plus from 0 to 5, 2 dx. This part we know, we're given it. This one we have to think about a little bit. This I'll need to draw a picture for. So this is really talking about the function y equals 2. So I'm going to draw that up here, which is a straight line. It says we're going from 0 to 5. And we're talking about the area underneath the curve here. So from 0 to 5, and so we're talking about this area right here. Well, the area underneath the curve will be base times height. The base is 5 and the height is 2. So that means that this area happens to be 10. So I'll replace this with the 10 and I'll replace this with the 4 for a combined area of 14. This next one has the plus 2 on the inside the parentheses, which makes the problem different. Well, these bounds refer to your x values. So what we're going to do is we're actually going to change our bounds, and you can do this. We're going to take and we're going to plug -2 in for here. So that means that our new bound would be from 0, because -2 plus 2 is 0, and we're going to plug in 3. 3 plus 2 is 5. So now we just simply have an integral from 0 to 5 of f of x dx, which is the information that I was given up top, and we know that this area is 4.